Let's take a look at Secure Sockets Layer, or SSL. SSL has kind of morphed into something called Transport Layer Security, which is abbreviated TLS. Now, I borrowed this graphic from an old Microsoft book. I don't think it's any longer in print. So let's look at and how this works. And if you've ever ordered anything online or went to a secure website, anything that's HTTPS, you've actually used SSL in the background. So this is all going to be initiated by a browser, i.e. 6 or 7, Firefox, etc. The browser initiates the this process. So this is number one. A request is sent to the web server. The web server responds back to the browser with a digital certificate, and one of the things that the digital certificate contains, the most important thing it contains actually, is the public key of the server. Now at this point the browser has the public key of the server, and there's a negotiation that happens. Are we going to use a 40-bit or a 128-bit session key? So after this is negotiated, the browser generates the session key, a session key, and uses the server's public key to encrypt it. So at this point what you see right here is the encrypted session key being sent across the public network. The server has its private key and decrypts it. So at this point we have the session key has been successfully transmitted. If you remember back when we talked about symmetric encryption, I pointed out to you that it's fast, but the problem is how do you get the key transmitted to both sides of the conversation? Well, we just accomplished this using asymmetric encryption. So at this point, number 6 here is the session key is used to encrypt the rest of the transaction, whatever that transaction may be. If you're ordering something online, that's obviously the transaction. If you're transmitting data or something like that, that's the transaction. But again, note what's going on here. We're using asymmetric encryption to transmit the session key from one side of the conversation to the other, and then after we've got the session key transmitted, we switch to symmetrical encryption and actually use the session key as the key for encryption and decryption because it's faster. So this is an example of how we use both symmetric and asymmetric encryption in a real-world application, and this is done every minute of every day. This is very important technology, and you really need to understand how it works. I'll post this web or this PowerPoint on the web, and this particular slide has rather detailed notes on how this works. So again, to review here, what technologies are at work here. SSL uses asymmetric cryptography to safely transmit the session key across the network. And then it switches to symmetric cryptography and uses the session key to encrypt, decrypt the rest of the information transmitted to and fro. And once this particular session is over, for example, if you order something online and 5 minutes later you go back to the same website and order something else online, there's going to be a new session key. So anyone intercepting the encrypted communication is going to have a limited amount of encrypted or ciphertext to analyze to try to crack and determine what your session key is. And even if they do manage to somehow ascertain what your session key is, you've only used that particular session key for a limited amount of time, and there's only a certain amount of information that's encrypted with it. Meanwhile, you're using new session keys regularly. So this minimizes the effect, just in case someone did magically somehow figure out how to crack your session key for any particular session. So again, you really need to study this. You need to think this through. You need to understand this technology because it's out there. It's used for not only ordering things online, but several other really interesting applications.